All right, hey folks, we're going to be talking about graphing inequalities here. So as I get started, I'm going to take some notes. Actually, I think I'm going to put some notes on the back side of the worksheet, 5-1, and then you guys we'll take a look at some examples on the front side. So let's get into it. So if I take a look at the worksheet here, I kind of labeled this inequalities, okay, making sure that we have symbols, what they mean and how they're graphed. But what does inequality mean? It means that things aren't equal. And how are they not equal is what we're going to be looking at. So I'm actually going to start out with a symbol that's not an inequality. It's actually an equality. I want to start out with that right there, equal. Okay, well, what is the meaning? It means equal to. Okay, and how do we graph it? Well, on a number line, if I want to say that x is 5, if this is 5, I'm just going to put a solid dot right over the top of that. Okay, you graph an equal to with a filled in circle. Okay, let's go ahead and do something like this. Okay, does anyone know what that symbol represents? Well, the bigger part is to the left, so when we read from left to right, it's greater than. Greater than. Okay, and so on the number line, if we have something is greater than something else, we're going to have an open circle. It's not equal to it, but the arrow off of it, we create a ray, is going to be pointed to the right because it's greater than. Bigger numbers would be to the right over here. Smaller numbers would be to the left. Okay, so again, greater than. The next one I'm going to put down is this one, and you can probably guess. This would be less than. Okay, so again, on a number line, it is not equal to, so it's an open circle, and we're going to the smaller portion where the smaller numbers are, which would be less than. Okay. If I go ahead and do this right there, does anyone know what that line underneath represents? That is or equal to. So this would be your greater than or equal to. Now, it doesn't change very much from what we saw in this second example here. It's still going to be greater than or equal to, but the or equal to is going to be filling this in right here. Okay, so you may remember that from years past. The last one, if you've already guessed it, is less than or equal to. And you probably guessed it, going to be less than or equal to. Okay, so hopefully you've got those directions down. That's what the translation of all those inequalities will be. So let's take a look at the front side. Okay, now the nice thing about what we're going to be looking at is things don't change just because we threw some inequalities in here. So you can actually treat this as m minus 6 equals negative 4. So what would you do to get m by itself? Well, you would probably go ahead and add 6 to both sides. Okay, so m is going to be greater than, that symbol doesn't change, comes straight down, okay, is going to be greater than 2 because 6 minus 4 is 2. Okay, now as I graph this, I'm going to find 2. It's not equal to it, so I'm going to put a open circle there, and it's greater than, so I'm going to go to the right. Okay. Now, an answer to this inequality would be any number to the side of that open circle. So let's pick 6. If I plug in 6 here, is 6 minus 6 bigger than negative 4? 6 minus 6 is 0. That is bigger than negative 4, so I am good. Okay. The next one. In order to get x by itself, I'm going to add 5 to both sides. That gets rid of the 5s over here. So we have this. Now, what I've seen in years past is that students read better left to right. So we're going to put the x on the left-hand side. Now, what does that do to our inequality? Well, it flips it. Okay, so it says x is less than or equal to 17. So if I was to go out here to 17, I'm just going to make a random mark here. and I'm going to go ahead and do less than or equal to. Well, because it's or equal to. Okay. So if I was to pick any number out here as a part of the solution, if I pick 0, 0 minus 5 is negative 5. Is 12 greater than or equal to negative 5? You betcha. Okay. So again, just solving for the variable. If I go ahead and do this next one, plus 7. Okay. N is less than or equal to 5. So if I do 5, I'm going to pick 5 here. 5 minus 7 is negative 2. Is negative 2 less than or equal to negative 2? It is or equal to, so therefore it is an answer to that solution. Okay. All right, moving on to the second examples. As these examples get a little more crowded, I'm going to subtract 5. You notice in the first couple problems all we did was add. So y is less than negative 12. So I'm going to go out here to, let's say, negative 12, less than, okay. So if I pick a number, let's say negative 15. Negative 15 plus 5 is negative 10. Is negative 10 less than negative 7? It is, okay. Next one, subtract 4 from both sides. So I get 4 less than or equal to x. Remember, I would like you to switch those. Okay, so 4 is greater than or equal to, x is greater than or equal to 4. So if I pick this, or equal to, so if I go ahead and do like 6, is 6 plus 4, is 8 less than or equal to 10? 6 plus 4 is 10? It is. It's smaller than 10. Okay? Now, as we look at numbers, number 3, I'm going to combine the like terms before I do anything. So 4v minus 3v is 1v. Negative 4 minus 7 is negative 11. Now to get v by itself, I'm going to add 11 to both sides. Okay, now again, I like to write them so that I can read from right to, or left to right. So v is greater than or equal to 16. Just greater than. I read it as greater than or equal to. So if I pick a number out in here, just to see if this is correct, this is 20. I'll pick a number 20. And if we do this, 20 minus 11 is 9. Is 5 less than 9? It is. Okay. So as these problems get more and more difficult, don't get scared by this. Okay. So in the next one, if I distribute this negative 6, okay, and bring the a's together. So we have a minus 12 is greater than or equal to 12. If I add 12, a is less than or equal to 24. Okay, so let's think about this for a second. If I were to plug in, let's say, 24 itself, 24 plus 2 is 26. And we're going to multiply that by negative 6. And then we're going to add 7 times 24. And it says, is 12 less than or equal to 12? And the answer is yes. I don't know if you can see that very well. I did all those calculations there. So it's 12, and that is less than or equal to 12. Now, I'll pick a number down in here. I'll pick 0. 0 plus 2 is 2. 2 times negative 6 is negative 12. Plus 7 times 0 is just 0. So is negative 12 less than or equal to 12? And it is. Okay. So there you go. Sorry, I didn't know I cut off that last part. All right. Want to finish out this last little bit. It says decide if inequality is always true or give a counterexample. Okay. So I guess what I'm thinking on this first one would be this. If I go ahead and try to get the variables to one side. I think it's good to plug in numbers here is actually the best thing to do. But will A minus B be less than A plus B? And the answer is sometimes true, okay? And that would be if B is always positive, okay? So if I were to do something like this, let's say that A equals 6 and B equals -6. If we plug this in, that's 12, and that's 0. And that is not a true statement, okay? Now, if I were to make both these positive, let's say 6 and 4, so I would have 6 minus 4 and 6 plus 4. So 6 minus 4 is 2. 2 is less than 10. And we've got something working here. So I'm going to put down that this is sometimes true. Okay, sometimes true. A has to be bigger than or equal to B. So probably going to put always true here. Let's just pick some numbers out. Let's say that this is 9 and 7, and C will be 2. Okay? So 9 plus 2, is that bigger than or equal to 7 plus 2? And the answer is that will always be true. 11 will always be greater than 9. Okay? So again, the second one is always true. The last one, if A is less than B, then A is less than B plus C. I'm going to say sometimes, I think. Let's see here. Pick a number that's less than. Let's put 2 and 4. And let's say that C is a negative. So 2 is less than 4 plus -2. So 2 is less than 2. That's not a true statement. Okay. So that would be not true. If C were a positive value, so we change this to a positive 2. 2 is less than 6. That is a true statement. Okay? So this, again, is sometimes true. All right, so hopefully that cleared up some things as we looked at that. If you have any questions, come back and talk to me. I think you have some practice problems in Schoology. So good luck with those. Let me know how you do. Thanks for listening. Good night.